All right, this video is all about something called the chi-squared test for independence. So the X that you're seeing right there, that is the Greek letter chi. So this is called the chi-squared test for independence. This is still part of our statistics unit. Basically what we're looking at is a test to determine whether or not two variables are related to each other or if they are independent of each other. So this is a little bit of a lengthy process, so I'm going to go through it once as just kind of an overview, just to give you an idea of what this is all about and some of the vocab and how it works and how the test works. And then I'm going to go through one very specifically step by step for exactly what you would do for any homework problem or test question, and how to use your calculator as well. So if you're watching the video, you should be having your calculator handy so that you can follow along with that too. So here we go. So a random sample of 200 teachers for high schools, secondary, and primary schools, men and women. So somebody went and did a survey of 200 teachers, and they gathered all this data. And so they organized it within a table, separating it out gender versus the level that those teachers teach. So ultimately what this is all about is somebody is trying to determine on whether or not gender has anything to do with the level of school that teachers decide to teach. And so that's what's being tested here. So ultimately what they're trying to determine is whether or not gender has anything to do with level taught. And so by the end of this test, the last thing that we would do is make a conclusion as to whether or not these things are related or whether they are independent of each other. And so this was actual data that was gathered. This is called the observed data because somebody actually observed this. They actually gathered this from a survey. And so that's the first part of this test, is just the gathering of the data. This is and organizing it into an observed data table. So that's what we have right here. And so you can pause this at any time and read through. This same PowerPoint is available on my website, so you can always go through the PowerPoint on your own separately as well. So here we go. So they're just giving you a little bit about how we're, the chi-squared test and what it's accomplishing with what we're going to do. So here's going to be the first step that you do within any chi-squared test, and this would make sense. We're doing kind of a scientific process here, and so the first part of that process would be to state a hypothesis. And then ultimately what we're really doing with the test is determining whether our hypothesis is going to be accepted or rejected. So for the first part, the hypothesis that we're always going to state is something called the null hypothesis. So this is the null hypothesis. This is the notation. An H with a sub-zero is the notation for null hypothesis. And the null hypothesis simply says that the two items are independent of each other. Well, if the null hypothesis says that they are independent, then the alternative hypothesis would just say the opposite. It would say that they are dependent. But for IB purposes, the IB test only ever asks you to state the null hypothesis. So that's all we're ever going to state. So we're going to keep this as simple as possible here. So we always start by stating the null hypothesis, which states that the two events are independent. In order to get credit for a proper null hypothesis, two things need to be accomplished here. One is your statement needs to relate to what is being tested. So in this case, we are testing gender and level of education that is being taught. So we need to address that within our null hypothesis. The second point is you need to use the word independent. So here's a good case right here. This is a good statement that would qualify as both points for a null hypothesis. So age taught and is independent of gender. And you can reword that a little bit, but just need to include the word independent, and you need to include the two items that are being compared to each other. Keep in mind, there is something called an alternative hypothesis. This would just state that the two events are dependent on each other, that there is a relationship, but that's not the one that you're going to state. You are always going to state the null hypothesis. So that's where the test begins, is stating the hypothesis. The rest of this test is now going to go through to determine whether or not this statement is true, so that we can end with a conclusion. So this is the same data table that we already showed on the last slide. They're now just going to throw in some totals here. So straight down, you're going to get the column totals. Straight across, you're going to get the row totals. And in the bottom right corner, we have what we call the sample total. So there are 200 teachers total that were surveyed for this. And now it's just been organized into this table. When we do things into a calculator, because in a minute here I'm going to show you how to use your calculator for just about everything. When you use the calculator, do not ever include totals in your calculator. Okay, the calculator only contains the observed data, never the totals. The totals are here for some of the things that you're going to be asked to do by hand. Even though everything can be done in the calculator, there's going to be a test question here and there that is going to ask you to show how to do certain things by hand. And so that's where the totals come into play. And so that's why they are there. Let me move on. So there's our total. There's our observed total. So the second table that is going to be created is something called the expected frequency table. The expected frequency table is one of those things that can be done in your calculator, but it can also be done by hand. You're going to just about all the time do it in your calculator, but once in a while there's going to be a need to show how to do something by hand, and so this is how you would do it by hand. The expected frequencies are probabilities of these things occurring. So to do any of these probabilities, there is a little formula here. So let me just highlight one area of the table. Notice there are 6 main cells within this table. To find any one of those 6, let's just say you wanted to find males in higher education, the probability of a male in higher education. Well, based on this formula, I'm going to take the male row total of 80 times the column total of 34 and divide it by the overall sample total, which is 200. That would give me the expected frequencies for this box right here. And you can do that for any of these 6. Obviously, it would be tedious to do all 6, so you're never going to have to do all 6 by hand, but there will be a test question that's going to ask you to show how to do one specifically with a formula. Let me show you one more. So again, let's just say you wanted the expected frequency, or the probability, same thing, of a female in secondary education. So if I look at this box right here, this represents the females in secondary education. So I would do the female total, 120, times the column total, 94, divided by the sample total of 200, and that would give me the expected frequencies for females in secondary education. So that's a way of doing it by hand. I'll show you later how to do this on the calculator. So anyway, all this stuff that you see here at the bottom of your screen is all the expected frequencies that could either be done by hand or by calculator. Those 6 values. So there is something else in here called the degrees of freedom. Because of the calculator use, we don't really make use of degrees of freedom anymore. This was something that was needed with some of the older methods when you had to refer to like table values and charts and things like that in order to get all of your information. For our purposes now, the degrees of freedom is simply something that you're going to get off your calculator. It's a really simple concept. The degrees of freedom, this is another case where there is a formula for this. You'll get it from your calculator on every problem. However, there will be a test question from time to time that will ask you to show how this is done by hand. So for that question, this is the little formula that you would use to do it. It's really simple. You take the number of columns minus 1. So right here I have 1, 2, 3 columns. So this is going to be 3 minus 1 times the number of rows minus 1. So I have 2 rows. So 2 minus 1 is 1. And if I just multiply this answer times this answer, I get the degrees of freedom. And so that's what you're seeing right here. It's the number of rows minus 1 times the number of columns minus 1. Whoop. And that gives you the degrees of freedom. But this is the little algebraic formula that's used to get that. But like I said, we're going to pretty much get this from our calculator anyway. Okay, here's how the test works. We have the observed data. This is the data that was gathered from a survey. And we have the expected frequencies. And this is the formula that I showed you a couple slides ago. What the test does is it compares what actually took place to what you expect to take place based on probabilities, and it compares those two things to see the likelihood of all of this coming together to whether or not the information based on these compare to these and whether or not they're related. So there's a formula for this, but here's the good news is you don't have to know this formula, and you'll never have to do this by hand. I'm just going to show it to you so that you can see that there is actually a formula for this. And for any IB student who chooses to use chi-squared for their internal assessment project, this is something they would actually do by hand. So here's the formula. It's really not that complicated. It's just lengthy. It's the observed frequencies, that's these guys, minus the expected frequencies, that's these. You square those, you divide it by an expected frequency, and then you take the sum of all of that data. And so that's what this would look like if you did all that. And this is the chi-squared value that we come out with. But this is something we're going to get. That 11.3 is something we can get in a calculator. So you don't have to be able to do this by hand. This is just something I wanted you to see. All right. So the last stage of this is to write a conclusion. So how do we know whether the null hypothesis, so remember the null hypothesis said that gender is independent of level of education. So is that accepted or is that rejected? And that's kind of where we end things, is to state a conclusion as to whether or not it is accepted or rejected. There's two ways of doing this. One way is to compare the chi-squared value, this, to something called a critical value. That's one way of doing it, but that is the old method of doing it. That's something that required charts and tables and things that we don't have to use anymore. So even though that does work, it's not a method that we any longer use. And so let me get to the method that we now use. And that is something that we use called, we compare something called the p-value, which is something you get from the calculator, to a significance level, which is a percent that's always going to be given to you within a problem. So this would always be given to you. Again, this is called the critical value. I'm sorry, this is called the significance level. This was the critical value. This is what we no longer use. That's the old method. So the new method uses a significance level instead of the critical value. So the significance level is going to be given to you. If it's ever not given to you, just use 5%. That's kind of the standard. If there isn't another one given to you, is 5%. So here's how this works. Really simple. So what you're seeing in green is the old method of doing things, comparing the chi-squared value to the critical value. We no longer use that. We will now use the p-value and compare it to a significance level. So here's how the p-value works. This is how you determine your conclusion. If the p-value, this is what you get from your calculator, is less than the significance level, this is the percent that will be given to you within the problem, then we reject the null hypothesis, plain and simple. And that's all you would have to say is I reject the null hypothesis because the p-value is less than the significance level. If the p-value is greater than the significance level, then you accept the null hypothesis. And that's it, plain and simple. It comes down to one of those two statements. You either say we reject the null hypothesis because the p-value is less than the significance level, or we accept the null hypothesis because the p-value is greater than the significance level. That's it. That's all you ever look at to determine your conclusion, and that's where this process ends. So I want to go through with you what is expected of you for every problem, every chi-squared problem that you do. So here we go. I'm going to get to the calculator stuff here in just a minute. So have your calculator handy. This is all calculator stuff, so you can always refer to this if you ever need to come back to this. But I'm going to show you how to do these things as we go through a problem together. So here we go. So here's a problem that would be given to you, and for every problem there is I'm going to come back to this slide here in a minute, there is a 5-step process that you can take on every problem. Oops. So here we go. This is something I'm going to give out to all the students in class. These are the steps that you take for every chi-squared problem. The first thing that we do is we state the null hypothesis. Right? There's the notation for it, H sub 0. To state a good null hypothesis, these two things have to be true. So you have to relate what's being tested, and you have to use the word independent. So that's going to be the first step that we do. Here's the second step that we do, is use your calculator to get all the information that's needed with all of this stuff. So I'm going to show you how to use the calculator. So we'll get there. That's going to be the second thing that we do. The third thing that we do is to state these values. These are all the things that you get from your calculator. But as I mentioned, you should know how to do some of these things by hand as well. You should know how to get the degrees of freedom by hand. And that was this little formula here. You should know how to get the expected frequencies by hand. And we went over that as well. That came with a little formula right here that we saw on an earlier slide in order to get expected frequencies. So these are two things that even though you're going to get these from your calculator, you should know how to do them by hand. There will be a test question for each one that will ask you to show how to do it by hand. So we'll address that as we go through a problem together as well. But for the most part, we're really going to use our calculator on all these problems. The last thing that we're going to do is to state the conclusion with a reason. So really important. Here's the last step. This is where every one of these ends, is to state a conclusion. And you'll either say, I accept the null hypothesis, and literally that's all you have to say. I accept the null hypothesis, or I reject the null hypothesis. You're going to be asked for a reason on all of your test questions. So if you say, I accept the null hypothesis, you're going to give a reason as to why you accept the null hypothesis. You're going to plug in the p-value, use real numbers. So whatever the p-value is greater than the significance level. So typically 5%, but sometimes that can change. But we're going to put real numbers in there for our reason. If you reject a null hypothesis, then you're going to give a statement like this, but again, with real numbers, not words. So those are the 5 steps that we're going to take for every process. Quick side note, and I'm just going to mention it. This was the old reason for conclusions, is to compare the chi-squared value to the critical value instead of what we're going to do. So I just want you to see this, because otherwise students always wonder, why in the world do I need to know the chi-squared value? And what is the critical value for? Because you're going to see these within the problems, but we never use them. So I just wanted you to know where those are coming from. Those come from an old line of reasoning for determining our conclusion. So there was a purpose to those. We just don't really use those anymore for what we do now. So I'm going to go through those 5 steps on one problem. So if you're still watching the video, that's what we're doing here at the next stage. All right, so I'm going to move through this fairly quickly, so feel free to pause the video if you need time to do something here. But anyway, this is what would be given to you. This is a typical problem. This is data that was collected. This was observed data that somebody collected from a survey, and they're basically comparing gender to the color of car that they drive. And ultimately what they're trying to determine is, does gender have anything to do with the color of car that people choose? So that's what they're testing, and that's where the chi-squared test comes into play. So step 1 is to always state the null hypothesis. So a proper null hypothesis for this must relate the items that are being tested. So we need to relate gender to color of car, and we need to use the word independent. So a proper null hypothesis, let me go to it, would be something like this statement right here. Color of car is independent of gender. So notice they used the word independent, and they also compared the things that are being tested, color of car and gender. So as long as you do those 2 things, you would get all the points for your null hypothesis. So that's step 1 on every problem. Step 2 is to use your calculator. So this is where the calculator comes in to perform the chi-squared test. And this is where you start getting all of your information from your calculator that we wouldn't really normally have to do by hand. So we're going to switch over to the calculator for a minute. Take note of these 4 pieces of data. These are the 4 things that I'm going to put into my calculator. So either write these down or you can do it with me when I put it into my calculator, but those are the 4 things that are going to go into my calculator. Alright, so here we are on the calculator. So here's how this works. So right here you have a button that says matrix. So hit second matrix and we're going to go over to edit. And we're going to just always use matrix A, so just hit enter. So we're going to create the matrix that would match the table that you were just looking at on the PowerPoint. So this has 2 rows and 4 columns, so you need to type in 2 enter 4 enter. So 2 enter 4 enter, and then you go through and just type in all the numbers that were in the table exactly the way that we saw them. And I already put those in here, so those are the 8 values in the exact locations that we already saw from the table. Make sure those are right. If those are wrong, everything for this whole problem will be wrong and you lose all the points. So really important that you put the correct numbers in there, so double check those on a test. Once you've done that, we've now completed the matrix, so I'm going to hit quit. So I'm going to hit second, quit, go back to my main screen. So once you've done that, we're going to go into stat. And remember, this is the chi-squared test. So we're going to go over to tests, and we're going to go down to the one that has the chi-squared symbol. Oh, there it is right there. Option C says chi-squared test. So we hit enter, and your calculator is going to do all the work. You just keep hitting enter. So the observed data was in matrix A. That's where we put. Your calculator is now automatically going to do matrix B for you, and they're going to put all the expected values in there for you in the matrix B. So you just hit enter all the way down. Enter, enter, enter. All right, so we got 3 main pieces of info here. So if you look at step 3, let me pull down. So step 2 is what we just did in the calculator. Perform the chi-squared test. Notice that I did not include totals in the matrix that I created. I just put the observed data, no totals. But these were the steps that we used to run the chi-squared test. So step 3 now would be to state the chi-squared value, the p-value, and the degrees of freedom. And all 3 of those are listed for you right here. So we're getting all those from the calculator. Quick reminder, you should know how to get the degrees of freedom by hand. So in this case, we had 2 rows and 4 columns. So if I did 2 minus 1 times 4 minus 1, that would also give me my degrees of freedom, which are 3. So that's something you should know how to do by hand, but we're just going to use the calculator to get it. So that was step 3. Step 4 is to write down the expected frequency table, and we're going to get that from the calculator. So you're doing step 4 right now, and you got to do this for every problem, is to write down the expected frequency table, but we're going to get that from the calculator. Even though this is something I did tell you, there is a formula for this, and this is something you need to know how to do by hand. You'll be asked for this on a test question to show how to get this by hand. So know how to do it by hand, but for all of your homework problems, we're going to get it right off the calculator. So this is the graphing display calculator steps that I'm going to take right now in order to get my expected frequency table. So I'm going to go back into matrix. So I'm going to hit second matrix. I'm going to be under the names column, and I'm just going to go down to matrix B, and I'm going to hit enter, and then enter again, and voila, there's our expected frequency table. So you're always going to round these to 3 sig figs if they're bigger. These are already 3 sig figs or less, so I'm just going to keep exactly what I see here. But this is my expected frequency table, so I'm going to always write this down for every problem, exactly the way you see it here, and label it expected frequency table. So you should always be able to write that down. You're going to get some questions that may ask you, what is the expected frequency for males who drive a red car? And so if you looked at here we go. So if you look at the matrix we're working with, well, males who drive a red car, that's the first row, column first row, column 3. So if you look at your calculator in the first row at column 3, 27.5 is the expected frequency values for males who drive a red car, and that would be my answer. And you're going to be asked some of those questions, but this is where you would find it. All right, so we listed our expected frequency table, and the last thing that we're going to do is state our conclusion. So here we go. So we're now going to state our conclusion. So here's how we finish this off with a proper conclusion. Is we need to say one of those two statements, and we need to give a reason with some real numbers. So keep those here in mind for just a second. So if you look at what just took place within our calculator, here's how we would need to finish this off. So from our calculator, this is the p-value that we got, rounded to 3 sig figs, of course. This is a significance level that would be given to you within the problem. So they would tell us that it's 5%, which, if we're going to compare these numbers, I need to compare decimals to decimals. So I'm not going to see this as 5, I'm going to see this as 0.05. So you're always bumping that over 2 places. So here we go. Obviously, 0.105 is greater than 0.05. So based on our conclusions, we're going to say I accept the null hypothesis because 0.105 is greater than 0.05. And so you're always going to be asked to state a conclusion and to give a reason, and this is how you would earn all the points. Please notice that for the reason, I'm using real numbers. Don't say that your reason is because the p-value is greater than the significance level. Don't use words, use numbers. If you put words here instead of numbers, you don't get any credit for that. So it's really important that you use the real numbers to state your reason, but that's it. That's where all these tests would finish, and it's those 5 steps that you're going to do for every problem. I'm going to go back to the PowerPoint really quick, just so in case you're still watching and you want to see how that finished off for them, I'll show you. So here was their observed data. They now put in the totals, but keep in mind we don't use the totals in our calculator. Here's the expected frequency table, and this is the same set of numbers that we got from our calculator, right? The expected values that you see down there at the bottom. Again, to get any one of those, let's just say you wanted to get, by hand, females who drive a black car. So you would do the female total of 130 times the column total of 96 divided by 260, and that's what this formula is telling you to do right here. But you only have to do that if required on a test question, not in your homework. So degrees of freedom, again, we got that from the calculator. Again, the way of doing it by hand is if you did the number of rows minus 1 times the number of columns minus 1, you can get the degrees of freedom that way as well. But again, we're going to be getting that from our calculator. So they ran the chi-squared test, 6.13. That's the same chi-squared value that we got. Remember, we don't really use that in our conclusion anymore, but you always are going to be asked what it is. So be in the habit of writing it down. That's something you should always state for every problem to 3 sig figs. So they went on to come up with their conclusion. Again, this was the old way of doing it, would be to compare the chi-squared value to the critical value, but we don't do that anymore. Instead, we would compare the p-value to the significance level, which is 5% for this problem. So that's what we would have done, and that's what I showed in the video. So there you go.